right, let's get started. Okay, so yesterday you had your lab, and about 256 of you have completed it, which is good, but that leaves another almost 100 that haven't. So it's really important to do that lab because it gets you ready for the first assignment. It's not something you want to put off until next Thursday. Try to get it done this week. I know some of you have hit snags trying to do various things, and so we can help you after class. I've just posted sort of a temporary consulting schedule for the rest of the week. So there'll be TAs in the CADE lab Thursday and Friday. You can look at that schedule. I'll be in my office tomorrow afternoon having office hours. So if you're having trouble, see one of us, get it ironed out so that you don't have to worry about that going forward. The tomorrow or Friday, depending on how fast I work, the first problem set will go out and it'll be due next Thursday. Also, the ZyBook assignments for next week will go out at the same time. Yes?
In regards to the ZyBooks assignments and the lab, should Canvas have our updated grades in there at this point?
Okay, he's asking if you've done stuff on ZyBook, if you've done stuff done the lab on Gradescope, should you expect the grade to be in Canvas yet? No. The grades don't get from Gradescope to Canvas until I push them up, which I haven't done yet, and the same deal with ZyBook. So as long as it's recorded on Gradebook or ZyBook, you're fine. Gradescope. Any other questions or problems, issues? Yes?
With the ZyBook, there'll be like a schedule, like they'll just tell us like, you need to regret to by here for this.
Yes, so there's, right, so what I do is every week, at the end of the week, I put the reading assignments for next week, and it shows up as an assignment. And it shows you what sections to read, and then you do the participation activities before each lecture. Even if you're in the hybrid section, you still need to do it by 3 o'clock on the day of the lecture. And then the challenge activities in that reading are due on Friday. Any other questions? Okay. Anyone still looking for an add code? Just a couple people? Okay, so the word I got was that Tracy stayed late yesterday and dealt with every request she had received by like 7:30 last night. And then she was going to resume working this morning on other ones that had come in. This is on a bunch of classes, not just ours. So if you made your request before yesterday at 7:30 p.m., you probably ought to re-request. Otherwise, you should hear from pretty soon. We'll let people in. Looks like we're not going to have a problem with space, so we're good. So just persist, and as long as you have the prerequisites anyway, she'll let you in. Right? Any questions about that? Okay. We're going to start learning about Java today. And before I do that, before we look at any Java, I want to talk a little bit about languages. Okay, so we're going to talk about syntax and semantics. So it'd be good to know what those words mean. What is when someone says the word syntax, what does that mean to you? Yeah?
It's like the structure of language.
You said the structure of language. Okay, anyone have a different take? Yeah?
The grammar.
Okay, you said the grammar. Yeah?
For like English, it's like the way you arrange words in a sentence.
Okay, you said for English, it's the way you arrange words in a sentence. Yeah?
So rules.
Okay, rules and
I say
set of procedures. Okay, so if I put it in one word, I say that syntax has to do with the form of language. Okay? So it's sort of the rules for what makes in English, it'd be the rules for what makes a legal sentence. And for Java, the syntax is the rules for what makes a legal program. Now, if you're speaking English, and you don't, let's say you're speaking or writing English, and especially if you're speaking, and you don't quite get the syntax right. Maybe your verb doesn't agree with the noun somehow. are instead of is or whatever. Can you still be understood? Sure. You can abuse English pretty radically and people can still figure out what you mean. The same is not true of programming languages. Programming languages, there's a syntax. If you leave off a semicolon, your program won't run. You make the tiniest mistake in the syntax of a programming language, of a program, the program's not going to run. And that's sort of the difference between having, when you speak or write English, you've got typically another person trying to understand what you're saying. But when you write a Java program, it gets translated by a program called a compiler into something that can run. And that compiler is a program that's very picky. Now you can imagine a future, the technology behind compilers is pretty old. Nowadays, computers can understand spoken English, and it seems like they ought to be able to understand, computers can understand spoken and written English. It ought to be able to understand, be more flexible about how it processes programs when it compiles them. But for the time being, it's pretty strict. Okay, I just blew it. Then there's semantics. Semantics has to do with meaning. So syntax is the rules for writing something down, the rules of a language. Semantics refers to what does something mean. So to give you some examples here, here's an English example. So what do you make of this, those words? Is that syntactically correct English? No, it's just a list of words. So that's an example of a syntactic mistake. You don't, a big syntactic mistake. Doesn't make any sense to arrange those words in that order. Okay? So that's syntactically incorrect. What do you make of this one? Is that syntactically correct English?
Yes.
Yes. It has a subject, it has a verb, it has an object. The adjective is modifying the object. It's got some prepositions in the right spot. But again, what's strange about it? What does it mean? The phone tasted the purple idea. That just, you might see that in a poem. But you're not going to see it in a technical paper. So I call that semantically incorrect. It's syntactically correct. It sort of scans as English, but it's not. You have a hard time figuring out what it means. What does it really mean? And I'm sure that linguists could debate about whether that has a meaning or not. But you sort of get the idea. And then finally, I just change a few words and I say the dog tasted the purple food, and suddenly, you'd agree that you know what it means. So that's good, I guess. It's neither syntactically incorrect nor semantically incorrect. Right? That's English. So let's look at Java. Okay? Most of you don't know Java, but if you look at that, does that look like something that you would see in a Java program? I mean, what are the clues? Yeah, I told you last time, often you see semicolons at the ends of statements.
There's just a number before the equals.
The number at the beginning. I mean, what you take is weird depends on how much you programmed before, if at all. But if you hadn't programmed at all, if you just knew sort of conventions of mathematics, what stands out? What stands out?
The parentheses don't enclose anything.
Yeah, parentheses look weird. I mean, you wouldn't see parentheses like that even in English. So that's just that's all garbled. Okay, so that's syntactically incorrect. This is a syntactically correct Java statement. It would have to be embedded in a larger program to do something. And what it's saying to do is we're going to take x and y and add them, divide it by 3. That'll give us a number. We're going to store it in a variable called average. Okay? So syntactically correct Java. Okay? Is it semantically correct?
No.
Okay. So why is it not? Why is its meaning wrong?
Because you want X and Y.
Doesn't X and Y have to be declared before it can be?
Yeah. Well, x and y have to be equal. So that's why I said it has to be embedded in a larger program. But yeah.
Because if you're averaging x and y over the 2 items, you should divide by 2.
Right. So to say this is semantically incorrect, we'd have to understand what we had intended to do. And if we were intending to average 2 numbers, we need to divide by 2. Okay? So this is semantically incorrect. Now it would run. The program would run. It would just do something. It would just compute the thing not a thing that we had in mind. Okay? And what would it take to make this semantically correct? Yeah, divide by 2. Now, we could quibble. You'll find out eventually that dividing, when you're dealing with integers, is kind of wacky and might be unexpected. The result might be unexpected in Java, but that's not my point today. So that's good. So here's what your experience programming is going to be like. You're going to have an assignment next week to write a program. So you're going to write the program, and maybe probably you'll make a lot of syntactic mistakes. How will you know you've made a syntactic mistake?
That's a red square.
Eclipse will put red squigglies under things. Now, if you type type something like that into Eclipse, it would mark it as being incorrect, but if it tries to give you a reason why it's incorrect, it would have a hard time saying exactly what's wrong with that, because there's so much wrong with it. But it's unusual that you would type something that way. So Java's giving you help. It's telling you about the syntactic errors in your program and helping you fix them. Once you've got them fixed, then you can compile and run your program. That's when things get harder, because the program doesn't work, let's say. Let's say you run the program and it doesn't do the right thing. It produces the wrong output. Well, Eclipse isn't going to help you. It's not going to say, oh, you made a mistake and you divided by 3 instead of 2. That's what you've got to discover on your own. And that's a lot of the challenge of programming. Getting the syntax right, at first it's strange, you're not used to it, you make a lot of mistakes, but gradually Eclipse trains you to stop making mistakes because it keeps pointing them out, telling you how to fix it. Once you can write syntactically correct Java, then the problem becomes getting a program to do what you really wanted it to do. And that's a challenge. That's something we'll try to cope with all semester. You'll learn about tools in Eclipse that help you see what's going on and help you figure out what's going on, but you have to provide the brain power of it. Okay. My main topic today is to talk about some concepts known as expressions, types, variables in Java. Before I do that, I want to skip to a Java program and talk about it in more detail so I can put this discussion of expressions into context. What do I want? This. Okay, so this is a new program. It's similar to a couple, or at least one that we saw last time. And I'm just going to talk you through it. We'll study everything that I talk about in a lot more detail. But if I'm going to ask you to write a complete program, I need to at least explain all the pieces of this program. So first I'll just tell you the problem you'll be solving for the assignment is going to be it's going to end up with a program that looks similar to this. It's just going to be you'll be taking input from the user, doing couple simple mathematical calculations and displaying results. And you'll be doing that in the same fashion this program is, by using pop-up dialog boxes. So I often tell beginning students that a good way to get going on a program is to try to remember think of an example that was done in class or in a book or something that's as similar as possible to what I'm asking you to do, and use that as a starting point. So what I would suggest that you do is when you get to working next week or tomorrow or whenever it's available on the assignment, start with this program or some other example that's similar and modify it to do what you need to do instead of trying to type it in from scratch. Okay? So anyway, let's look at the pieces. So the first thing I want to focus you on is not the whole program, but this part right here. So it turns out that when you write Java programs, what you're doing is creating classes. So a Java program is one or more classes. And that's all you need to know for now, except that a class has a name. All right, so this class is called area. All right, so you're creating classes, and when you create a class, it turns out you put more than one class in a file, but for our purposes right now, let's just pretend you only put one class in a file. The name of the class has to match the name of the file. So you see the file is called area.java. And the file's area.java, the class is called area. That has to match up, or you'll get a complaint. So I can show you here. If I change this to R, then I get the message that the public type R must be defined in its own file. It's basically telling you that's a misleading message. It is in its own file, it's just the file has the wrong name. Okay, that fixes it. Okay, so we got that working for us. So we're defining a class. Very first thing up here, package CS1410. Well, there are lots of classes out there. There's a library that comes with Java full of classes you can use, and we'll learn to use some of them during the semester. And it's hard to keep them organized. And so the way they're organized conceptually is in packages, and you can think of packages as sort of a synonym for folders. So essentially, that's the statement up there, package CS1410. It says this class will be stored in the folder called CS1410. And again, what I told you isn't absolutely true. It's probably not the perfect way to describe packages, but it's the right way to think about it. So let's go with it. So do you see any evidence up here in Eclipse that area.java is stored in a folder called CS1410? You have to look outside of the program. Yeah.
Yeah, over on the side there.
Yeah, up here, this is called the Package Explorer. It shows, when I expanded my project here, it showed me, here's the source folder, and inside the source folder, so all the code goes in the source folder. Here's CS1410 package, and it contains area.java and inches.java. So that package there has to match the folder that it's stored in. So for example, if I took area.java and moved it outside of that folder, then, oh, it didn't even do it. Oh, it copied it. That's weird. Oh, look what it did. So I thought I was going to move it, but it actually moved it. When I moved it, it copied it. And what did it also do? It fixed it for me. It removed the package declaration because it's not in that folder anymore. So that's not what I had in mind. So let's skip that. Instead, let's just change the package. I'm trying to create an error. Okay, so I changed the package. I look at the message, and it says the declared package CS1410X does not match the expected package CS1410, and it'll either offer to move it to a different package. So if I clicked here, it would create a new package over there on the left, new folder, and stick the program in it, but I just want to change the declaration back to CS1410. So that works. Okay, so that's what packages are. So we've got classes that are stored in folders, and we sort of have to say what the folder is up there with that package. So far, so good. Any questions about that? Yeah?
Are they exclusively for keeping your code organized?
Yeah, they're for keeping your code organized. Not just your code, but also you'll discover that the Java library has hundreds or thousands of classes in it, and they're organized into packages. And the advantage of that is, there may be another class in the library called area, but if you put it in your own custom package, it won't be a problem that there's multiple packages with the same classes in them. Okay, any other questions? All right, now, here's the next thing up here, import. And I just mentioned there are lots of classes out there. If you want to use a different class, some other class in writing your class, you have to say so. Except there are a couple of exceptions for really commonly used classes, and we'll see them later. But for right now, let's just pretend that if you're going to use a class, you need to import it. So we're telling the Java compiler that we're going to use the class CS14lib.java, CS1410lib.dialogs. We're going to use that class in the program. And its job is the compiler has to go out and find that class. Now, if it's in the Java library, it'll find it. Turns out that's not in the Java library. You wouldn't expect there to be a CS1410lib package in the Java library. So where is that thing defined? How is the compiler going to find it? Right? That's a reasonable question to ask. So let's look. Here is this folder called lib for library. And inside it is something called CS1410library.jar. So that's basically a zip file containing the compiled version of the code that is included in the CS1410 library, which is code that I wrote. So anytime you use the Canvas project manager to create a project, it puts that library in there for you to use. And that library, among other things, provides the way that show input dialog and show message dialog. So, as long as I have to set up the project to contain the library and to reference it correctly, and that's a little tricky. That's one reason I use a CPM, so it's automatically set up for you. You can use those methods. There are like 4 methods in there. We'll see 2 of them today. Okay, so folder the classes in. Then we say what classes we want to use, which ones we're importing, and then we have the class. Now, when you implement a class, there are various things you can put inside a class. What we're going to put inside the class is a method, and in particular, we're going to put that method right there, main. And what was the reason we saw last time for why you do that? Why do we create a method called main? Yeah?
There has to be a main method in every single class.
Right, there has to be a main method if you want to run the program. Because when you run the program, it starts by running the main method. Now, students always ask, so I'll ask for you, why public? Why is that there? Why static? Why is that there? Why void? Why this thing here? And the answer I always give is, I don't feel like explaining it yet. Just declare it public. It turns out things can be private, but it doesn't make it, I don't want to explain what public means until I get to the point where I can explain what private means. It's not worth explaining until there's a difference. Static. Some methods aren't static, but again, until further notice, methods are static. Void means something I don't feel like talking about. I will talk about it next week. And then the parameters to main, I don't want to talk about either. So if people that don't like Java, one thing they don't like about it is that when you declare the main method, you got to type a lot. Okay? Turns out you can, when you create a project, you can ask Eclipse to stick the main method in there for an empty main method. Or you can do what I do and just copy it and paste it. There's a website called publicstaticvoidmain.com, which is a place with information about Java. So anyway, I wish I didn't have to say, let's not worry about it. But when you're writing a main method, just start with that line, and we'll worry about exactly what it means later. For now, it's just math. All right. Now, I keep using the word method, and you don't see the word method there. What is a method? Yeah. A way of okay, a way of doing things. That's good. Yeah.
So there's 2 types called functions and methods. Aren't methods defined inside of the class, and functions are outside of the class?
No, in Java they're just methods, and they're always inside classes.
So the main thing that they do is they make it so that you can condense code and you can basically repeat various amounts of code without needing to repeat.
All right. So these mention some of the advantages of methods. Basically, a method is a sequence of statements, of Java statements that do something that you can give a name to. And then when you want to do those things, you can just say run main, and you don't have to repeat yourself. We'll talk about next week a lot about methods and their advantages. But for right now, think of it as just a sequence of statements that does something. Do you have a question? Or?
Oh, I was just gonna ask, like, is it like when you have like the command to say average this number, that's a method in the sense that if you don't have to add them all up and divide it by the number of numbers.
Yeah.
That method?
Yeah. Well, for example, we can see methods are used inside of main here. So what we're doing here is defining a method called main. So it's just a named bunch of statements. Right here, we're using a method, showInputDialog. So the dialogues class provides a method called showInputDialog that does something interesting. It brings up a dialog box, waits for the user to type something in and click OK, and then gives back to whoever used the method the actual string that was typed. So we don't have to, we talked about this last time, abstraction. We can call showInputDialog. We can use showInputDialog without knowing anything whatsoever about how it's implemented. It's just someone, namely me, created it, gave it a name. As long as you know the name, and a few more pieces of information, you can use it. Okay? And so we're creating a main just so we have a program to run. So that's that. And then inside the method is a sequence of statements. This one has 5 statements. They're executed in order from top to bottom. And that's where, we'll spend a lot of the semester learning about how do you write statements to interesting things. Because there are lots of different kinds of statements. So rather than talk too deeply about this, who could summarize what that highlighted statement does? What does it do? Yeah.
Pops up a input dialog that tells you to put in a radius.
Okay. So it pops up. What's going to happen when that's executed? Dialog box pops up. It will contain the string enter radius of circle in centimeters. The user will then type and hit enter. And what will happen to whatever the user types? Yeah, it gets stored into that variable input. So I'm getting a little bit ahead of myself, but the idea is after that statement's executed, the variable input will contain, it'll be another name for the string that was typed in by the user. Okay, then we get to the next statement. And what it's going to do is it's going to take that string, and again I'm getting ahead of myself, turn it into a number, store it in that variable radius. Then, what's happening here? Okay. Go ahead.
Okay, so it's taking the radius and then putting it to the exponent of 2. So dividing
So it's
radius by
squaring radius.
and then timesing it by pi, then setting it equal to the area W,
Okay.
which is a floating point.
All right, so the highlighted code is going to compute pi r squared. It's going to take the radius and square and multiply that by pi. And it ends up being stored in that variable area. And if you look at PAL and you say, whoa, what does PAL mean? Which would be a reasonable thing to ask. How would you find out? Right? One way you can do it is Google it. You could say, what does math.pal do in Java? Or if you're using Eclipse, you can just hover the mouse, and it'll usually have more information than you want. And so the trick is to learn to read like the first line. Return the value of the first argument raised to the power of the second. And then if you're interested in the fine print, you go read the fine print. What happens when, weird situations. So that's good. And the same thing works with show input dialog. Now, how does Eclipse know that's what show input dialog does? Because I wrote the code. It didn't come with Eclipse. Yeah.
Isn't that like a class that exists in the Java library?
No, it's not a class. It's a class that exists in my library, CS1410 lib. So, yeah.
The way you documented it when you commented it.
Right. So if you look at the code that I wrote, you see the comments here. Prompts the user for the radius of the circle and reports its diameter. I have a comment in my code that says, builds up a dialog that prompts the user for input. And that's where it's getting that comment that I wrote to show you when you hover the mouse. Yeah?
So if you don't comment that out,
Right.
so it would never show up.
If I hadn't put that comment in, you wouldn't have much help here. And we will stress the vital importance of putting comments, and that's one reason. It makes it possible for people to figure out what your code does without having to read all the code in detail. Yeah?
So you just mentioned the comment, and it says reports its diameter. Isn't it reporting the area?
Yeah. Okay, so that's we could, what kind of mistake is that? Is it a syntactic mistake or a semantic mistake? Right. Thank you. All right. And I won't belabor things and look at all of the statements right now, but you sort of get the idea. Now, what if I said, okay, I want you to write a main method that prompts the user for information about their car. I want to input the type of car, like Mustang or Sonata or whatever. I want to input the capacity of the gas tank. I want to input the miles per gallon that the car gets. And I want to I want to get the price of a gallon of gasoline. And what I want the program to display is how much, several pieces of information which I can't remember. I just described the program I want you to write. So you go calculate, maybe how much it would cost to fill up the tank and stuff like that. I should have read the assignment before I got here. Is it a big jump from that program right there to the program I just described? It shouldn't be. How do you? But you're going to have to prompt multiple times. How will you prompt? You're going to say, "Give me the name of the type of the car. Give me the price of gas, and so on." How are you going to adapt this to do that?
Well, you'll have to do the dialogue box and then store it, and then do the dialogue box
Yeah.
and then store it.
You just have to do this more than once.
Those first two lines.
Yeah. And then you'll have to do some other calculations. You have to change the calculation. And then, there's going to be, I want you to get the answer in a single message box. And so you're going to have to build up a string that contains the whole answer and then display it. So it's, it's not a huge jump from that, but it takes some work. Yeah.
So you said to do multiple inputs, you'd have to put that multiple times. Where would that go? Like on which line or where?
Well, let's say that you needed to, instead of the radius, you had to get in the radius and you also had to get in the x and y coordinates. So what you do is, you could calculate the radius that way, and then just take those two statements and copy them, and paste it and change this to, it doesn't like you to declare the same variable twice, so I will do that. Then we say enter radius of circle, let's say enter x coordinate.
Did you get rid of string or inputs?
Okay. That's what you have to do to get it to get all the red out. So now I've got it, so it's asking the user, in fact we run it now, you'll see. Enter radius of circle, let's say 56, I say okay. Enter x coordinate, 87, okay. And that gives you the area, 9852 point something. We're not doing anything with the x coordinate right now. So if you can do one thing, you can do the similar thing again. So the fine point that I sort of skipped over, to use a variable you have to declare it somewhere, and that's that. Then you can use it. But you can't have the same variable twice. You can't redeclare input in the same method body twice. So I'm just reusing input. Now why did I declare x here instead of reusing radius? If we stored the x inside the radius variable, we've lost the radius. So why don't I worry about losing the input, the value of the input variable? So I take in a string the user entered, store it in input, convert it to a number, and store it in radius. Yeah?
Because you don't care if it replaces it, because you want to replace it, so it
Yeah.
shows the correct thing.
I don't need it anymore, so I might as well just reuse the same variable. Now maybe, I can imagine people being purists and saying, I don't like that style of programming, and so you could sort of do input 1, and then declare input 2, and then you have to go, these variables I have to change. Okay. So it's a little more symmetrical. The first pair of statements, the two pairs of statements are sort of exactly symmetrical. Your question first.
Why didn't you get an error when you went on line 19? You didn't have a string input. Like when you ran that, you didn't get an error despite not having a string.
Well, the only thing I wasn't doing was I wasn't. It was a perfectly well-formed program. I just wasn't making use of x. Yeah.
Couldn't you also nestle the dialog show input box into the input 1 and the input 2 so that you don't actually need to declare a string beforehand, so you're not allocating that memory?
Yeah, there's other tricks we could play, and you'll see more about that later. Yeah.
Just so I understand, so when you didn't have the string, you just had input. That was just changing the value of input for anything that came after.
Yeah.
Is that how it works? So like,
Right.
if you would have put that statement up, then it would
Right.
the first
So-
couple parts gold, and then it just changes as you go down.
Right. So let's go back the way I had it. So input. So I'm just going to use input everywhere. So change that to input. Okay, so what you can imagine is that when your Java program runs, there's a little man in the computer with a piece of paper doing what you tell little man to do. And so little man here puts up the input dialog, gets back a string and writes it on the piece of paper right next to where it says input. So the input is 47. Then converts it to the number. What's the little man going to do with this statement here? He'll display the input dialog, get a string back, and he's going to take this piece of paper and scratch out the old thing that was written next to input on this piece of paper and write the new thing. He's just reusing it. Now, do you see, why is X underlined in yellow? That's a new one. It's hard to see, but yeah.
It's being used right now.
It's what?
It's not being used right now.
Right, so it's a warning. So if you hover it, it's going to say the value of the local variable X is not used. So it's not an error, the program will still run, but Eclipse is saying, you know, if you went to the trouble to calculate X and never used it, maybe there's a mistake. So it's trying to help you find a semantic mistake there. Yeah?
Why was the yellow thing not
What was that?
there? Why was the yellow one not there last time?
Because we didn't, it wasn't in the original program because we didn't use X. It's been there ever since I put that statement in that involves X. If we use X later on, it would go away. Yours.
That's kind of a dumb question, but why can't you just do X equals a parse input? Why is the double necessary there?
Okay. So this, what we're doing here is calling a method. And the name of the method is parse double. What is double here? That's a class. So to call a method, you got to give the class, it's called static method, which is all we care about right now. You give the name of the class it's contained in, followed by a dot, followed by the name of the method in the class. Now, I said up here you had to import all the classes that you use. So I imported dialogs, and you see it here, dialogs.showInputDialog. Dialogs.showMessageDialog. How did I get away without importing double here or there, and also math down here, math.pal. I did not import math. Yeah?
It's one of the standard ones that Java just gives you.
Yeah, there are a few packages that it just automatically imports. Really commonly used classes, and math and double are a couple of them. Yeah?
What is the double that's in red before radius and X and radius?
Okay, so he's asking this highlighted double right here, what does that mean? And how's that different from this one right here? The case is important. Capital D double is a name of a class. That lowercase double is something else, but I'm not going to tell you right now because we're going to, I'm going to clear that up a little bit later today. Are there any other questions? Okay, start there. Okay, I gotta get a little closer. Oh. Okay, so she's asking a question about another thing that would appear. She's asking about int, I-N-T. And she was wanting to substitute it in for string, I think. Is that right? Yeah, that wouldn't do the right thing. We'll talk about what int means as well. So what's happening is I'm starting to get questions about variables, types, and expressions, which was actually the name of the slides I started with. So let's take our quick break, and then we'll learn about variables, types, and expressions. refresher, it should be this. That class is intended for
That's what I got for the first 2 sessions.
So you need my permission to edit that. Okay, so just talk to Tracy. So, yeah, so fill out the form and then before you talk to me, and she'll contact me to verify. What should I do? This video is over here. Yeah, I mean they're different.
Well, I mean, the inputs.
So the input? I'm not sure what you're asking.
Yeah, the different products.
Oh, okay. So there, when you highlight that, it shows you all the places it's used. So it's just saying that input parse is this variable. Sometimes you want to see everywhere.
Why they're in different colors.
Because this is a declaration, and this is where it's used.
So on this challenge activity, the one where it's like output the string, this is my submission, and it passed all the tests. I'm just wondering if there's a more compact way to.
That's for what you did there. That's the easiest way to do it.
Okay.
I mean, you can write a program to generate permutations.
Okay.
Be a lot more complicated.
Yeah. Okay.
That's what I'd expected. I need to get started, so I can get your after class. All right, let's get started again. Okay, I just noticed that at the very beginning of the video, it's going to say spring 2019 because I forgot to change that to fall 2019. So don't be worried about that. Okay, so I promised you to talk about expressions, values, types. So let's do that. Okay, so an expression is a piece of a program that has a value. So thinking back to that class I just showed you, is any piece of it, what would be a piece that doesn't have a value? That's kind of a hard question because I haven't told you what a value is. Okay?
If I had to guess, it'd be the comments.
Oh, sure. The comments don't have a value. It's not part of the computation. The package declaration at the top. Okay, when I say it doesn't have a value, I don't mean it's not important. I'm getting ahead of myself. So let me explain what a value is first. So let's look at, so I just said it's a piece of program that has a value. So these are examples of Java expressions. If you see 7 in the program, that's an expression. If you see false, that's an expression. If you see 8 plus 14, that's an expression. If you see the string hello, that's an expression. And expressions have values. You can look at an expression and ask, what is its value? So what is the value of that first expression? 7. What's the value of the second expression? False. So some expressions, their value is just, 7 and false are called literals because their value, the value they stand for is literally the thing they're written as. On the other hand, 8 plus 14 is an expression, but it's not a literal expression. You have to actually do some computing to figure out what it is, and of course that's 22. And then the string hello, its value is the string hello. Okay. Here's some more. X is an expression. What's the value of x? X being a variable. Is it 2?
Anything you pointed to.
Turns out what's stored in the variable. So variables contain values. So whatever value x contains, whatever little man has written down, that's the value of x. 2 times x plus 5. Okay? So the value of x, let's say x contains 10. So that's going to be 25. Square root of 2. So math.sqrt is a method in the math class that computes the square root of whatever you give it to the square root of. And in that case, it will return square root of 2. And then those single quotes denote a character. So that's the character Z. So those are examples of Java expressions. So here's some things that are not expressions. So the import statement is not an expression. You would never ask someone, what's the value of that expression? You would never find import java.util.scanner plus 7 in the program, right? Because you only add expressions together. You don't add non-expressions to expressions. That method call right there, it does something. It prints out to the console, but it's not an expression. It doesn't compute anything. It doesn't compute a value. So every expression has a value, and every expression has a type. And to learn to program, one of the first things you got to do is understand expressions and understand types. And if someone points to an expression, you need to be able to figure out what its value is. So let's talk about values. A value is something that can result from evaluating expression. So that's sort of a circular definition. We're going to pretend there are only 5 kinds of values in Java. It's not true, it's not even close to true, but it's good enough for us today. There are integers, there are real numbers, there are characters, there are booleans, and there are strings. So for our purposes today, that's all we have. Integers, real numbers, characters, booleans, and strings. And all the expressions we look at, when you evaluate them, you'll either get out an integer, a real number, a character, a boolean, or a string. Okay? Now I'm sure you know what integers and real numbers are. And strings, what's a character? Yeah?
Single letter.
Like a single letter, digit, punctuation symbol, whatever. A string is a bunch of characters. There are different things in Java. And then what's a boolean? That's kind of weird. Yeah? True or false, a truth value. So if something is true or false, we call that a Boolean value, after George Boole. Yeah?
So like if you tried to store like one character as a string, would that make an error?
Well, we'll get to that. He asked what happens if you try to store one character as a string. Is that an error? It turns out it is, but we'll solidify that. Now there's a fine print. I said that Java has integers. Well, actually, it has 32-bit or 64-bit integers, which is another way of saying that if you have a really large integer, so if your integer is larger than about 2 billion, it's too big to be considered an integer in Java. Okay? So the integers in Java run from about minus 2 billion to positive 2 billion. Okay? Real numbers, well, it doesn't really have real numbers. It has double precision floating point numbers. And the way to think about that is the real numbers in Java behave like numbers on your calculator. You know, if you have an exponent that's real, like 1 times 10 to the minus 10th, your calculator will be happy. If you do 1 times 10 to the minus 1 millionth, probably your calculator is going to call that 0 because it's so small. So You can only have numbers that are so big or so close to 0 before they're considered infinite or 0. And if you try to write a number with 1,000 decimal places, that's too long as well, just like on your calculator. You can get maybe 20 decimal places. Right? Characters, well, you might ask, what alphabet are we talking about? We're talking about Unicode. So Unicode contains all the letters on your typewriter key, on your computer keyboard, but it also contains, all the letters or glyphs or whatever in natural languages that are used around the world. There was even a move to get the Klingon alphabet added to Unicode, which failed. So that's, I guess, not a natural language, it's a made-up language. Booleans are true and false, and strings are sequences of characters. Okay, so those are what things we'll be computing with our expressions. Okay? Now, a type is a name for a specific set of values. So back here I told you there were 4 kinds of values: integer, real numbers, characters, booleans, and strings. But actually, we spell, when we mention them in a program, we spell them specially. So if you want to use an integer in a program, it's called an int. Okay? So some values are ints. If you want to use a real number, you use the word double, lowercase d. So that just means real number within certain limits. If you want to use a character, char is the name we use. Boolean, we just use Boolean, with lowercase b. String is string with an uppercase s. Now you may think it's arbitrary. Why do we have uppercase s and lowercase everything else? We'll get there in a second. Okay, so those are the 5 types of values, and the types have names. Okay, they're variables. So variable is a name for a memory location that can hold a value. And a given variable can only hold values of a specific type. So a variable has a type for all time. The value can change, the type can't. So there, for example, we're declaring a variable called numPeople. We put the type of the variable in front of it when we declare it, and then after the equal sign, we put what we're going to initially store in the variable. So what's something, say we changed our mind and wanted to change numPeople to something else. Could we change numPeople to false? No. You couldn't change it to a string. You can only change it to another integer. Right? And that's, if you program in Python, that's different. Python has different rules. Okay? If we want a variable to hold a distance, maybe we declare it to be double. And then you can use the kind of, the sort of familiar scientific notation. Now, why are there ints and doubles? Why not just doubles? Yeah?
Double take up more space in memory.
Well, doubles are bigger, that's true. Yeah?
Integers are simpler.
Integers are simpler, they're faster, and they're exact. So when you say multiply 2 doubles together, you multiply 2 doubles on a calculator, you might get round off error. If you divide 1 by 3 on a calculator, you don't get the exact answer. It's truncated to some number of decimal points. Integer arithmetic is always exact, but doubles can represent far bigger and far smaller things. So you use integers to count. You use doubles for measurements. Okay? That's how you declare a variable of type char to hold a character. That's how you declare a Boolean variable. That's how you declare a string variable. Who was Ada Lovelace, by the way? Yeah, you know?
Wasn't she in the movie?
I don't know, she may have been in the movie, I don't know.
Wasn't she like in the military?
No, you're thinking of someone else.
No.
You're thinking of Grace Hopper. Yeah?
Does it kind of like Google it?
Kind of like what?
Is it kind of like Google it?
Well, we'll see if someone can do it that way. Okay, so Charles Babbage designed a computer that was, I don't know if it was mechanically powered, mechanical computer. He was never able to build it completely, because this was back like in the 1800s. And, but Ada Lovelace was the first programmer. So she wrote programs for Babbage's computer. I guess they've actually built his computer recently, so I guess in the end her programs. Anyway, she's the world's first computer programmer. Okay. Now, assignment is the only way the value of variable can be changed. And it just looks like that. If you want to change the value of num people to 15, you just give the name of the variable, followed by equal sign, followed by what you want to change it to. That's called an assignment. Now, how's that different from a declaration that I had up there before? Yeah?
You're setting the type along with the value.
Right. So if I put int in front, I'd be declaring a variable called num people and initializing it to 15. But right that way, it has to be the case that num people was declared earlier, and now I'm just changing its value. There we're changing the value of distance, initial, is open, and name. So that's just a basic thing, changing the value of a variable. But you can't do that. You can't take a double and try to store it in an int. You can't take a character and try to store it in a double. You can't take a Boolean and store it in a char. You can't take a string and store it in a Boolean. And you can't take an int and store it as a string. It's pretty strict about that. There are a couple of exceptions, except they're not really exceptions. If you try to store an int into a double, Java will let you, but it takes the time to convert it to a double. It just converts it for you automatically. Okay, here's the fine print. Int, double, char, and Boolean are primitive types. There are 4 other primitive types in Java, but that's all. We won't worry about the other 4 for now. String is a reference type. That's why it's in uppercase. Basically, a reference type is the name of some class that someone created. So somewhere back in the prehistory of Java, the string class was created. And by convention, classes start with uppercase letters. So every reference type is the name of some class. The other primitive types don't correspond to classes. And the difference is important. And there are tons of reference classes out there. Only 8 primitives, but tons of reference of classes. But for right now, we can safely ignore the difference. We'll come back to that. All right, so I've thrown a lot of things at you. These slides go on to talk about different kinds of expressions, but I prefer to demo it as to looking at the slides. So I'll do that. So what I'm going to do is bring Eclipse back up. I'm going to run JShell. Make this bigger. And hit enter a few times. I spent like 10 hours on the weekend trying to make this work. Finally. Okay. So one thing JShell is really good at is you type expressions and it'll tell you the value of the expression. So let's start with the simplest kinds of expressions. So given what I've told you, what are the simplest expressions out there? Yeah, 2, for example. And it tells you, it's just telling you that was expression number 1. And its value is 2. Okay? Another simple one would be true. So these are called literals, where the value is essentially the thing you typed in. If I type in 3.14, the value of that expression is 3.14. The value of x is the character x. The value of this string right here is that string right there. Okay, so literals are self-evaluating, if you will. So that's one kind of expression. What's another kind of expression I mentioned? What else is an expression? Okay, so they're expressions you create from operator symbols. So let's start with things you can do with ints. If you have 2 int expressions, you can combine them by adding them, and now you have a compound expression. And it's not hard for you to figure out the value of that expression. 2 plus 3 is 5. Okay? You can subtract, divide, multiply. But I'll just warn you, 7 divided by 2 is 3. When you divide 2 ints, you get an int as a result. 3.5 is not an int. So any remainder is discarded. This is integer division. Yeah?
Shouldn't it round up to 4?
Well, he says, shouldn't it round up to 4? Well, I don't know if there's any should or shouldn't. There's just what it does. It rounds down. Now, you may care about the remainder. You might like to know what the remainder is. There's another operator for that. It's called mod. So the percent sign is the mod operator. 7 mod 2 gives you just what's left over after division. So the slash gives you the quotient, the percent gives you the mod, the remainder. Yeah?
So then, how do you get it to say like 3.5?
Okay? What happens if we divide 7.0, which is a double, by 2.0? So once you put a decimal point in there, you're talking about doubles. Then you get to 3.5. So if you want the decimal places, you got to use doubles. So you can multiply, subtract, divide, and add doubles just like you can ends. Okay? Yeah?
Are there such thing as like triples?
No. Okay, that's a good question. He said, is there such thing as triples? It took me a second to figure out what you're asking. What he's really asking is, why is it called double? And I gave you a clue in that slide. Why is it called double? Yeah?
So all the numbers are stored as 0 and 1.
No, that's not why it's called double. Yeah?
Double memory.
Well, that's closer, yeah?
It's 2 different integers on each side of the decimal place.
Well, that's not it either, yeah?
It's a double precision.
It's double precision. So there's another primitive type called float. Float is a single precision floating point number, and double is double precision. It's twice the memory as a float. Floats aren't quite. They're annoying. It doesn't have enough decimal places. It doesn't have enough exponent. So I don't use floats. Just use doubles. These names, these type names, all come from C, by the way. The programming language C, which is from 1970. Yeah.
If you were to have it for some reason as a float, would Eclipse, if it say your math made it bigger than a float could contain, would it freak out or would it convert it to a double for you?
No, if it's a float and you make it too big, then it essentially just tells you it's infinite. Okay, so they're operators. I'll show you some more, but I want to show you something else first. What's another kind of expression other than literals and operator expressions? Yeah?
Assignment operations?
Well, assignment operation isn't, well, yeah, that's not what I mean. That's for changing the value of a variable. Yeah?
Logic, if something.
Well, I mean, there's true and false, but what I'm after are variables. So if I declare a variable like int n equals 7, I didn't type int n equals 7. So int n equals 7. Okay, what's the value of that expression? N. What's going to happen when I hit enter? Right, it tells me it's 7. So variables, the value is stored somewhere. It's looked up. So what if I do n times 3? It's going to give me 21. Okay? So variables are pretty simple. Now if I say n equals 15, so I don't like to say n equals even though I just said it. Let me stop for a second. People look at that and they think math. They think n is 15. Okay? But this is not symmetrical. This says take n and change its value to 15. So I say things like n gets 15 or n is changed to 15. If you say n equals 15, then you start thinking that should mean the same thing as 15 equals n, which doesn't mean anything. Okay? So I'll try to avoid saying equals. So n gets 15. So now if I say what's the value of n, it says 15. If I say what's the value of n times 3, it says 45. So that's another simple type. So we've got literals, we have operator expressions, we have variables. Okay? Now, let's think about, we looked at operator expressions, addition, multiplication, division. What about this one? What about, here's an expression, 15 greater than 10. So you can use, right. So it's two numbers being combined, two numeric expressions, two int expressions being combined with an operator symbol, but in that case, the answer is true. So the value of the expression 15 greater than 10 is true because 15 is greater than 10. The value of the Boolean. So what if we wanted to store the result of 15 greater than 10 in a variable? How would you do it? What type of variable do we have to use to store the result of that expression? Right, so we'd have to say Boolean b equals 15 greater than 10. Okay, and I said equal again. All right, so b contains true. What if I did this? What if I said b gets, well, I won't do that. Let's do n less than 10. What's the value of that expression? Okay, how do we know that? N is 45. No, n is 15. And 15 is not less than 10, so that's a false. Okay? Let me show you another. So you got you can use less than, greater than, less than and equal, greater than or equal, same as, not the same as. Okay? So if I wanted to find out is n the same as 15, it's going to tell me true. Now what if I screwed up and I said that? It changes n to 5. And that's a very common mistake to make. You're testing for equality, it's double equals. Yeah.
So the same as is essentially what you're trying to not say is equals though.
Yeah.
That is equals.
So this n double equals 15 means, are those two expressions have the same value? Do they have the same value? All right? So here's another one called and. So double ampersand, means if both sub-expressions, both the left and the right expressions are true, the result of the expression is true, otherwise it's false. Both have to be true to get true out. So what will we get out when we do that? False. Now what if we do this? N is greater than, so what is n right now? 5? Let's do n is greater than 4 and n is less than 6. Are both of, is n greater than 4? Is n less than 6? So the answer should be true. Now what if we changed it to this? N is still greater than 4, so that part's true, but n is not less than 5 because it is 5. And so the result of that and operator is false. Now if we changed it to greater than or less than or equal, true. There's also this. That is and, this is or. Vertical bar. People always ask me, where's a vertical bar on the keyboard? My keyboard is what you have to, it's way over, right above the enter key. It's on the backslash key. So a lot of keyboards, it looks like a broken line instead of a solid line. But anyway, that's or. So in this case, if either is true, the answer is true, otherwise it's false. So what's the value of that Boolean expression right there? It's true, because n is greater than 4. It doesn't matter whether n is less than 5 or not. On the other hand, if we do n is greater than 14 or n is less than 5, that's going to be false. So those are Boolean operators. Then there's this. We know that n is greater than 4, right? Now, if you put parentheses around something, you put parentheses around because you want to control the order in which things are done. Let me go back to where we were. Like right here. If I took the parentheses out, it looks kind of confusing. You might wonder, what does it do first? Does it OR the 4 and the n together? And let's see what it does. And it does the right thing. But I can never remember. So when in doubt, put parentheses around things like you would in a calculator to control the order in which things are evaluated. There are all these rules for what happens when there are no parentheses, but you just saw I can't remember them after all these years. So don't depend on that. So we've got n is greater than 4 is true. Then we've put it in parentheses, it means the same thing. It's still true. If you put an exclamation mark in front of a Boolean expression, that negates, that's a not. It says whatever the result of n greater than 4 is, give me the opposite. So what will not of n greater than 4 be? It'll be false. So we got and, or, and not that you can create expressions from. Okay, so that's a quick look at operator expressions. So what do we have? Operators, we have variables, we have literals. Okay, let me show you another one. Static method calls. So the way static methods work is you have to name the static method, like math.square-root, and a method is going to operate on one or more values that go to it. So you have to put one or more expressions in the parentheses. So square root only takes one. So what happens if we ask for the square root of 2 plus 7? What do you think Java goes through to evaluate that, to compute the square root of 2 plus 7? So first it adds 2 and 7 to get 9. And then it asks the square root method to take this 9 and do its thing. And that method gives back the answer, which is 3. So if you have a method, you know what it does, you can make an expression from it. Okay? What's 1.0 divided by 3.0? First of all, what type of thing will that be? A double. And its value is truncated to some number of decimal places. Okay? I'm going to show you a strange looking method called string.format. So let's break this down. This is an expression. String.format takes two parameters. The first parameter has to be a string, and the second parameter needs to be a double. Okay? Is the second parameter a double? Well, yeah, because that second parameter is an expression that involves dividing two doubles. We know that's a double. The first parameter is a string. Yeah, it looks like a string. So when I say parameter, I mean when you're calling a static method like this, you can give one or more parameters, the things that the method operates on. And if there's more than one, they're separated by commas. So anyway, it takes a string, it takes a number, and let's see what happens when we evaluate it. So what type of thing does string.format give back? String. And how did it decide to give me 0.33? Yeah? Yeah, so you just have to know that that first parameter is called the format string. What it's saying is, I want to get back a number in floating point format with two decimal places. Okay? So there are lots of methods out there. You just have to find them. So math dot cosine. There's probably a cosine method, right? Yeah, there's a cosine method. It uses radians. Okay, so as long as you know the name of a method, what do you have to know about a method to call it, to make an expression out of it? You have to know what class it's in. You have to know the name of the method. So math and cosine. What else do you need to know? Yeah, you got to know how many parameters to get it. Cosine wants 1. And you have to know what type of parameter it wants. It wants a double. And you just hook it up and it'll compute the answer for you. Let's go back to this program here. Let's find all the expressions in this program. So in this first line, this line right here, where is an expression? How many expressions are there? Well, name one expression. Yep. Okay. This is an expression. It's a string literal. Okay? That's one expression. There is one other expression. The whole thing is a declaration of a variable. But there is a piece of this that's an expression. Yeah?
Like the whole right half returns some
Right. That right there is an expression. What kind of expression is that? It's a method call. Okay, what about the next line? What expressions are there on the next line? Okay, what kind of expression is that? It's its type is string. It's a variable expression. And what's the other expression? The method call. Next line is the same. There's an expression. Here's an expression. Next line. There's an expression. Here's an expression. Next line. There's an expression radius. There's an expression 2. Here's an expression, a method call. What happens to the result returned by the method call? It's involved in a larger expression. So 2 is an expression that is part of a method call expression. That method call expression is part of multiplication expression. And this is something I haven't talked about. That's called a class constant. So it's just essentially an unchangeable variable declared in the math class that contains the value of pi. What about right down here? How many expressions here? Well, is this an expression? Right? That's a string literal. Is this an expression? That's a variable, and that's an expression. We're adding 2 strings. That seems odd. Let's go see what adding 2 strings does. So if you wonder about things, try it out in JShell. Let's add the string hello to the string there. So what does adding 2 strings together do? Concatenates it. Right? And then here, answer is the only expression on this line. Now you may think, what the heck? Looks like a method call to me. The difference is dialogues.showMessageDialog is a method that doesn't return anything. So technically, calling it is not an expression because it doesn't have a value. It just displays something but doesn't compute anything. Now I'm going to do one more thing before we stop. When I run this, and I enter 45, I get back too many decimal places. How could I change this so that I get back 2 decimal places? Okay, if I use that string.format, what do I want to format? Area. I want to convert area. Oh, actually, by the way, this is weirder than I thought. I'm appending a string to a double. How did that work? Down here, when I did the example, I appended 2 strings. Well, the secret is when you append a string to something that's not a string, Java automatically converts it to a string for you. So that's nice. We can replace area with a different expression, with this expression, string.format, .3f, .2f, area. So now talk me through what's Java going to do when it has to evaluate this big expression right here. So the first thing it'll do is it'll look up the value of area. What's it going to do with the value of area? Yeah? Well, it's going to pass area as one of the parameters to format and get back a string, which then appends on the other side. Then we throw the answer. I'll take one more question.
So with string format, you know how there's the 2 in the string format?
Yeah.
If you replace the 2 with like, let's say, 4.
Yeah, so if I said %.4, I'd get 4 decimal places. So I'll do that, and then if you got questions, come up and ask. Let me stop this here.